So there are L band, S band, C band, as well as there is the X band. So X band ranging from 8 gigahertz to 12 gigahertz. So 8 to 12 gigahertz is a X band, and for our practical we are using rectangular waveguides as a component or as a transmission line. And in case of that rectangular waveguide, all these waveguides are operating at X band. So it is from ranging from 8 gigahertz to 12 gigahertz. Then in earlier practical we had discussion on that experiment, that is study of microwave components and devices. In that experiment we had discuss about different components, like there is isolator, circulator, directional coupler, E-plane T, H-plane T, magic T. All these are microwave components. And then there are microwave devices, like there is klystron power supply, gun power supply, direct reading frequency meter, VSWR meter, match termination, detector mount. All these are microwave devices. So for generation of microwave, we are using microwave tubes, and they are called as microactive devices. So there is klystron, magnetron, and TWT. TWT means traveling wave tube. So a klystron having again different types, like there is a two cavity klystron, multi cavity klystron, and reflex klystron. So as far as this experiment is concerned, this experiment number 4 is more related to mode characteristics of reflex klystron. So anyone, you can tell me what is mode in case of waveguide? What is the mode in case of waveguide? So we can say that mode is a electric and magnetic field pattern inside the waveguide, and then there are 3 types of mode. Which are they?
Sir, TEM and TEM.
TE mode, TM mode, and TEM mode. That is transverse electric, transverse magnetic, and transverse electromagnetic. And then there are certain conditions related to the TE mode, TM mode, and TEM mode also present. Which one is dominant mode in rectangular waveguide? Which one is dominant mode in rectangular waveguide? So I will answer this. So TE10 is a dominant mode or the fundamental mode in a rectangular waveguide. There are 2 types of mode. One is called as dominant mode and another one is a degenerate mode. So dominant mode means fundamental mode, whereas degenerate mode means higher order modes in case of microwave. So for this particular experiment, the title is we have to measure as well as plot the mode characteristics of reflex klystron. Again, I will tell you that a klystron having different types, like there is a 2 cavity klystron, multi cavity klystron, and reflex klystron. So reflex klystron contain only 1 cavity. So when we see the diagram of a reflex klystron, so it contains only 1 cavity, and that cavity is called as anode cavity. This particular klystron is a microwave tube, and it contains electron gun which emits electron. To heat the electron gun, a filament is again needed, and there is, when filament get heated, electrons are emitted by using electron gun, and they are traveling from this particular anode to cathode side. And there is a repeller, or a repeller is a particular electrode. So repelling means opposing. So these electrons are opposed by other end by using repeller electrode, and they are travels backward direction using this repeller electrode. There is a potential like VA. So VA indicate the anode potential, and which one is a negative potential, and then there is a VR, which is called as repeller voltage. So this is the block diagram of an reflex klystron which contain only 1 cavity, and electron gun is useful for generating electrons, and through the process of velocity modulation and there is a electron bunching can be possible, and due to this electrons are converted into microwave energy, and then microwave energy can be taken out from this RF out at this particular cavity. So in detail working of this reflex klystron, you have to study about unit number 5. but we go for this title, like we have to measure as well as plot the characteristics of reflex klystron. Particularly the klystron used in this particular experiment is having model number as a 2K25. So when we search reflex klystron 2K25 in Google, you are having a data sheet for that particular reflex klystron. So this can be taken certain time. So this is Reflex Klystron 2K25, and it looks like this black color tube. And then there are certain characteristics of Reflex Klystron, like there are certain parameters or technical data, like it having heater voltage, then heater current. Also, it is having an repeller voltage range. Also, there is a particular voltage between cathode and heater and so on. So this is a technical data or data sheet of this reflex klystron, which is having a model number like 2K25. So in this particular model, it is used in our laboratory for performing this experiment. And when we go for a setup or block diagram of this klystron or this experiment, we need this klystron power supply, then it needed a klystron mount or klystron tube. Then output of klystron tube is given to the isolator. We know that isolator is a device which can transmit signal in only one direction. Then for measurement of frequency, a frequency meter is used. For variable, after that variable attenuator or slotted section you can connect. And then finally a Schottky barrier diode detector mount is present, which detect the signal and which is given to the CRO. So this particular experimental setup, in general, it is called as microwave test bench. So are you getting about this diagram, what it contains, or is there any doubt? Are you getting a diagram or experimental setup for this particular experiment? Yes or no? Am I audible to you?
Yes, sir.
Okay.
Yes, sir.
So I will prepare a video on this this microwave test bench. So first, see that video. Good morning, students. Today we are going for this experiment, that is mode characteristics of reflex klystron, and for that particular experiment we required microwave test bench setup. So as shown here, there is a microwave test bench setup present over here. So the first part of microwave test bench setup is an klystron power supply, which is needed to power the klystron. So klystron is this particular tube. So the black color tube present over here, so which is a klystron tube, and that is used as a microwave source. And as this particular tube contains a filament, and that filament get heated, so a heat sink is required for that particular klystron tube. So a fan is used as a heat sink for this particular klystron tube. After that, second part of this particular experiment or microwave test bench is an isolator with termination. So isolator is a microwave device which can be useful for transmitting signal in only one direction, means it blocks the reverse signal. The signal from klystron tube that is traveling in only one direction, that is in forward direction. After that, the third part of this microwave test bench is a direct reading frequency meter. So this is a direct reading frequency meter. Some readings of frequencies in gigahertz that should be shown over here, and there are one vertical red line and two horizontal red lines are present. How to match or how to measure the frequency using this direct reading frequency meter, I will tell you later. After that, the next part of microwave test bench is this is slotted section which can be useful for finding VSWR. of microwave signal traveling inside this rectangular waveguide, and finally there is a match termination or microwave detector is present in this particular microwave test bench. The last component is detector mount, DM, so which uses a Schottky barrier diode for detecting microwave signal, and then output of this detector mount is connected to a CRO. So this is a short introduction of microwave test bench. So what a microwave test bench contain? Microwave test bench contain a Klystron power supply. So output of Klystron power supply is given to Klystron tube. Klystron tube needs an heat sink because it is heated, it contains a filament and electron gun. Then there is an isolator which is useful for transmitting signal in only one direction. Next device is direct reading frequency meter, useful for measurement of frequency traveling inside that microwave test bench. Next part is microwave slotted section, that is useful for finding VSWR. And finally there is detector mount, which is useful for detecting microwave signal, and output of detector mount is connected to a CRO. So this is a video which indicating a particular microwave test bench. Means all these equipments are shown in that video. So it contains Klystron power supply, then Klystron mount, isolator, frequency meter, and instead of variable alternator, a slotted section is present over there. And that is useful for measurement of VSWR. Finally, detector mount is present, and output of detector mount is given to the CRO. So that about a particular microwave test bench. After that, we have to go for performing actual experiment. So there is a procedure for this performing experiment, like you have to connect the component and equipment as shown in this block diagram. Then you have to set variable alternator, but we are not using variable alternator, so this step number 2 is not used. Then step number 3 is you have to set mode switch of Klystron power supply at AM position, means we are using amplitude modulated wave here. And then you have next procedure is you have to set beam voltage, and that beam voltage is set to 300 volt. You can go for less than that voltage also, so it may be 250 volt or it may be 300 volt. And then you have to change the repeller voltage slowly and watch the CRO for deflection of waveform. So whenever we found the deflection of waveform, that is treated as the first mode of reflex response. Again, you have to rotate the, if you want to find out the frequency of wave inside that waveguide, then you have to go for rotating that frequency meter, and you have to stop rotating until you are having a deflection on waveform on CRO. Whenever a deflection is observed, that frequency you have to measure, and that is the frequency of wave inside that particular frequency meter. And then in this way you can plot a different mode, means you have to repeat the procedure for different mode. This is a particular observation table. Here there are certain points, like you have to observe like frequency, repeller voltage, and output voltage. Output voltage is observed on CRO. Repeller voltage, or it is also called as reflector voltage, it is observed on Klystron power supply. And frequency meter is useful for observing frequency. And for each mode you have to take 3 different reading. One minimum reading, then maximum reading, and another one is minimum reading. So for each mode you have to take these 3 readings, and you have to plot these readings according to this particular graph. So this is the procedure, and I had prepared a video also for that procedure, or explaining that procedure. You will see here. Okay, so after that we have to discuss about Klystron power supply. As this Klystron power supply contain number of buttons, so there are buttons like first one is function select. So there are options like you have to go for CW, that is continuous wave. Then AM means you can provide amplitude modulated signal. You can provide FM, that is frequency modulated signal, as well as there is facility that you can provide an external modulated signal. And then second knob, this is display select, means what you want to display on this display screen. Either you want to delete, either you want to display voltage, either you want to display current, or either you want to display repeller voltage, that is REP voltage. Then this bottom buttons are beam voltage. You have to set beam voltage using this beam voltage knob. Then reflector or repeller voltage. Then amplitude and frequency of AM signal and FM signal you can control by using this. And then there is button like standby and off. So first we will switch on this power supply by pressing this on button, and now display switch is at current position. So you can set to this voltage and it indicates the voltage, that is the beam voltage. Then after that there is this particular knob. You have to set this knob to the AM, that is amplitude modulated signal. You have to send amplitude modulated signal as an input, and then you have to go for this beam voltage. You have to adjust this beam voltage to 250 volt. So you have to rotate this particular knob until its value is equal to 250 volt. Says here the beam voltage is equal to 250. After that you have to go for this amplitude and frequency knob of AM. It should be in midway position, so you have to modify that. And then we don't using this FM, so we don't need to go for this FM knob. After that, output of this particular Klystron power supply is connected to this Klystron tube, and finally output of detector mount is connected to a CRO. Channel number 1 CRO is active and it is connected. After that, next step is that you have to set repeller voltage. So you have to first move this knob to the repeller voltage, and before this repeller voltage you have to check the beam current. So as that filament get heated, now it is 18 milliampere, but as that filament get heated, its value is increasing. You have to take precaution that this value does not increase more than 25 milliampere. If its value is more than 25 ampere, then you have to close that knob, means you have to switch off this Klystron power supply. You have to wait some time for that particular filament to be cool, and after that you have to again start. So point is that this beam current is not more than 18 milliampere. So what we do up till now, we will set this beam voltage to 250 volt, then beam current we will check it is not greater than 25 milliampere, and then finally we will go for this repeller voltage, REP, that is repeller voltage. And this is a particular knob. By varying this particular knob you can check this repeller voltage. Now initially its value is at maximum position, so it is 227 volts. But what we do, we want to find out more characteristics of this particular Reflex Klystron. So we have to move this button of reflector voltage in anti-clockwise direction, so it can be reducing from 227 until you are having some waveform on CRO. So I have to reduce this repeller voltage like 227 and then 210, and I have to do until I have a waveform on CRO. So I will reduce this, and at this particular voltage, so here voltage is equal to 193, I am getting a particular output, that is a square wave is present and it is detected by detector mount, and it should be present over that CRO. So we can say that this is the first mode of this Klystron. Again you can remove or reduce this repeller voltage. Again there is a change in waveform that can be present over here. So this indicates the second mode of Klystron. Then again there should be third mode of Klystron, and so on. So a Klystron having number of mode, and as you reduces the repeller voltage, now everyone listen here, I don't set vary this beam voltage. I am only varying this repeller voltage. So repeller voltage should be in reducing manner. Initially it is set to the maximum value, say it should be 227, and we have to move or we have to reduce that until I am having a certain waveform on this particular CRO. So this is indicating the first mode of klystron. Then second, this is we can say that second mode of klystron at 123 volt. Then there is a third mode of klystron also, so that is at 83 volt. So in this way you take the observation of this particular number of modes of an klystron, and for each mode you have to take 3 observations. So 3 observations how you can take, I will show you here. First, initially I will go for reducing this klystron until I am having certain waveform on until I am having a certain waveform on CRO. So I will reduce this and at this voltage 201 I am having a certain small waveform that should be present over here. So I will take this reading. I will go for this repeller voltage as 201 volt, and I am checking this output on CRO. So its value should be, say it should be 1, and then there should be 4. So it is 1.4 multiplied by channel number 1 having reading as 0.2 volt, means 1.4 multiplied by 0.2 volt. So this is the output present over here, and for this output I have to check the particular frequency also. So how to check frequency? So for checking frequency I am having a direct reading frequency meter here. So I will rotate this direct reading frequency meter until there is a deflection. You have to rotate in right side or you have to rotate in left side, but you have to rotate until there is a deflection in waveform is present. So while rotating you have to observe the CRO also. So see here, at this particular frequency there is a deflection in waveform is present. See here, again I will show you. I will rotating this, and at this particular frequency there is a deflection in waveform is present on CRO. So you have to note this frequency. So how to measure this frequency? So for measurement of this frequency, again you have to match the vertical line and bottom red line. So bottom red line reading is in between, it is exactly 9.76. So you are having an output of frequency that is 9.76 gigahertz. So here you are getting CRO output as a 1.4 multiplied by 0.2 volt for channel number 1. Repeller reading is 202 volts, and frequency reading is equal to 9.76. So after taking that frequency reading, again you have to deselect this particular frequency meter, means you have to rotate somewhere in left and right side, and after that again you have to reduce this particular repeller voltage for maximum output. So at this voltage 188 I am getting a maximum output here. So this output should be when we go for this, so it is nearly equal to 4 multiplied by 0.2 volt. And again I have to find out the frequency. Here the repeller voltage is 188, and again I have to find out the frequency. So same procedure you have to apply, means you have to rotate this and you have to rotate until there is fluctuation in waveform on CRO. So at this frequency, see here, I will show you. At this particular frequency you are getting the fluctuation in waveform. So you have to measure this reading. Again it is less than that the previous value. So that is previously it is 9.76, and here it is nearly equal to 9.73 gigahertz. So how to take this reading? We have to match the bottom red line and vertical red line. So it is matching at 9.73 gigahertz. We don't want to go for that vertical red line. We only have to select the bottom red line. And after that again you have to deselect that frequency meter, and again you have to take third reading for this same mode by reducing this repeller voltage again, and at this particular value, say it should be 182, you are getting a reduced output, so you have to again match, say it should be 1.4 multiplied by 0.2 volt. And again you have to go for this finding frequency by rotating this frequency meter, and you have to rotate until there is a deflection on waveform. So at this particular there is a deflection frequency, so it should be again nearly equal to 9.76 gigahertz. So in this way, for each mode you have to find out these three values, means there is two minimum point and one maximum point, and for each point you have to find out the repeller voltage, frequency, as well as the output voltage. So output voltage you have to set to the x-axis, and you have to measure the output on y-axis multiplied by channel 1 value. So in this way you can find out the mode characteristics of Reflex Klystron, and this procedure you have to repeat for this mode number 2 as well as mode number 3, and you are getting an output in observation table. And finally you have to go for plot. You have to go plotting a graph according to your observation values. So I hope you understood the procedure for this particular experiment. So for each experiment, you have to find out the, for each mode, you have to find out the frequency as well as repeller voltage and output voltage. Repeller voltage you can found on that Klystron power supply. Frequency you can observe using an direct reading frequency meter, and output voltage you can found on CRO. So are you getting the procedure for this experiment? Are you getting the procedure for this experiment? Yes or no?
Yes, sir.
See here, initially we are setting beam voltage to 250 volt, and beam current is 18 milliampere. There is restriction on beam current, that is beam current does not more than 25 milliampere. So when filament get heated, that beam current is increasing. When it is greater than 25 milliampere, then we have to close the Klystron power supply, and then it needed to be cooled. And after that again you have to perform the experiment. So the procedure is same. What we have do here, we will only reduce the repeller voltage until we are getting the first mode, and that first mode also we have taking three reading, that is first minima reading, maxima reading, and second minima reading. And after that you have to go for second mode, third mode, and similarly for each mode you can calculate frequency, repeller voltage, and output voltage. Frequency is calculated on frequency meter, repeller voltage calculated on Klystron power supply, and output voltage you are getting on CRO. And finally you can plot and graph like this is output voltage in millivolt on CRO versus repeller voltage. Similarly frequency versus repeller voltage. So repeller voltage is reducing, means for this mode, say it should be 200, then 180, and then 170. This is for first mode. And frequency again it is 9.76 gigahertz, 9.74 gigahertz, and finally there is 9.72 gigahertz. This is reading for first mode, which I had shown on that video. But same procedure can be repeated for this mode number 2 and mode number 3. It may be possible that mode number 2 you are getting at suppose it is 140 volt, then this is minimum reading, maximum reading at 130 volt, and again second minima reading at 110 volt. And for all these three readings you have to calculate frequency, and frequency again it is reducing, means At first minima it is 9.76 gigahertz, at maximum it is 9.75, and at minimum it is 9.74. So frequency is again reducing. So in this way you can plot mode characteristics of reflex klystron. So are you getting this experiment? Are you getting how to perform this experiment?
Yes, sir.
Yes, sir.
You need this type of setup for performing this experiment, right? You require an Klystron mount, and for that Klystron mount and Klystron power supply is needed. Isolator is again useful for reducing the backward waves. Then frequency meter is useful for finding the frequency of wave inside a rectangular waveguide, and it is a direct reading frequency meter. On that frequency meter, there are two horizontal lines and one vertical line is present. And for measurement of frequency, you have to match bottom horizontal line and vertical line. At which frequency it is matching, that is the frequency of wave inside that waveguide. And instead of variable attenuator in that video, we are using slotted section. That slotted section is useful for finding VSWR. And output of slotted section is given to detector mount, and finally detector mount output is given to the CRO. So this is the procedure. In short, I will explain procedure once again. First, you have to set beam voltage, and that beam voltage is set to 250 volt. Then second step is that you have to change the repeller voltage until you are having some deflection on CRO, and that can be treated as a first mode. And that first mode having again three different readings, like first minima reading, maxima reading, and second minima reading. And for each reading you have to find out frequency, and frequency can be calculated by rotating that frequency meter until there is a deflection on waveform on CRO. And you have to repeat this procedure for second mode as well as third mode. So are you getting this procedure, or is there any doubt? If you have any doubt in this experiment, please ask. Am I audible to you? Are you getting all these procedures?
Yes, sir.
See here, initially this beam voltage is set to 250 volt and beam current is equal to 18 milliampere. As that filament get heated, the beam current is increasing, but it did not exceed more than 25 milliampere. And after that, you have to reduce that reflector voltage until you are getting output on CRO. And for that output, it is treated as a first mode, and you have to take three different reading, that is first minima reading, maxima reading, and second minima reading. Say for you are getting minimum output at 206 repeller voltage, then maximum is at 180 voltage, and again second minima is at 170 voltage. For that repeller voltage, you have to find out the output voltage. Output voltage can be found on CRO, and frequency can be found by rotating frequency meter until there is a deflection on CRO. So I hope you are getting the procedure for this experiment. And one more thing is that a model graph or model plot is present over here. When we compare this model plot with an data sheet of that Klystron, so it again having some model plot like here. This is a model plot. This indicate the first mode. This indicate the second mode, third mode, fourth mode, and so on. And this indicate the frequency, so which can be reducing one. Means for first minima reading, the frequency is 9.76 gigahertz. Then for maxima it is 9.75, and for second minima again it is 9.74. So this frequency is reducing. So we can plot graph like this output voltage on CRO with respect to repeller voltage, and frequency with respect to repeller voltage. So I hope you understood this particular experiment, that is mode characteristics of reflex Klystron. So right now we have completed two experiments. One is a study experiment, that is study of microwave component and devices, that is experiment number 3, and experiment number 4 is related to mode characteristics of reflex Klystron. Whenever we have opportunity to in college, then we can perform this experiment in person also. So less than 1 minute remaining. If you have any doubt, then please ask. Okay, so thank you for participating.